Welcome to Robominions.in AI interview preparation app. The topic of this video is Introduction to Singly Linked List. We'll look at the definition of node in a linked list. Then we create and display a singly linked list. Then we will look at the user defined linked list features header file. So first let's look into the definition of a node in a linked list. So node is a basic unit of linked list. Node consists of a data value part, you can see here, and a next node address or a previous node address, pointing to the next node or the previous node. The best basic example of node is the user profile in a social media site. Each individual user is a node consisting of a profile information, that is a data part, and linked with another user node with the next address part. So the structure representation of a node is we have struct node int data, struct node pointer next. So it's a pointer next is of type node, struct node. Now let's look at the code of tracing a code of creating and displaying data of a singly linked list. So stdlib has been included, then declaring create function, display function, and recursive display. It's headed to the int main. Now a data array is used. It has a value 10, 12, 23 and 44. This is the data which will be added to the linked list. So we use the create function, send the data array and also the size of the linked list. So it will be 4 nodes. So it goes to the create function. Here node pointers t and the last is created. So it's declared. Then we have first node pointer, which is assigned with a memory location. Location is with a memory address hash 200. It has a garbage value data and next node address. So now data is added. So the first node is added with the data array of the 0th element, that is 10. 10 is added. The next node address is kept null and last points to first. Now we are using a for loop to add the remaining elements of the data array. So the 0th index has already added as the first node. So we start I from 1. So I is equal to 1, I less than node count. So the node count is 4. So 1 less than 4, true. Now we are creating, we have the t temporary node. So t is allocated with the memory now, hash 300 memory location. Data is assigned, the index 1 data is assigned from the data array. So the data 12 is assigned to that node. Then next node address is null. Last next, that is last was pointing here, right? So the next address of the next is accessed and then it's assigned with t address. So hash 300 has been assigned as next node address of the last or first. And now last is moved to t. So last moves here. Okay. So now I is incremented. Now I is 2. Now another new t is created, a new memory location, hash 400. So now second index of the data array, data 23, is assigned to the data part. T next is made null. Now last is pointing here. So last next, the hash 400 is assigned to last next. Last is moved to t. Now I is again incremented. Now it's moved to 3. A new node T is created. It's allocated with a memory with address #500. Data is assigned 44. The I index is 3, so 44 is assigned here. T next will be null. Last next is assigned with 500, so #500 has been assigned, and then last equal to T, so last has been moved to T. Now I is again incremented. 4 less than 4 is false, comes out of the create function. Then we try to display the loop, display the linked list using the loop. So we go to display. We are creating a node pointer disp. We take the disp to first node. While disp is not equal to null, the first node is not null, so it goes to printf. It prints the disp data. So data here it is 10, so 10 gets displayed. Then disp is equal to disp next, so the disp moves to the next node. Disp is not equal to null, true. Now the disp data is 12, 12 gets printed. Disp is equal to disp next, so disp has moved to here. Now disp is not equal to null. Data right now is 23. Again disp is equal to disp next. It's moved to this node. Disp not equal to null, true. 44 data has been printed. Now disp is equal to disp next, that will be null. So while not equal to null has turned false, so it comes out of the while loop. So all the data in the linked list has been displayed. Now we try to do a recursive display using recursive function. So recursive display, you send the first node to this display. So pointer P is pointing to the first node now, you can see here. If P not equal to null, true, then it prints the data 10. Then it again calls the recursive display P next. So P has moved to next. So the new P, is pointing here. So now again P is not equal to null. 12 is displayed. P data is 12 at this point. Then again recursive display is called, which makes P next. So again the P is moved to next node. So P is not equal to null. So P is not equal to null. P data here is 23. Now again P is moved to this node, and P not equal to null, true, and P data is 44 at this location. Now when again P next is called, P becomes null and recursive function is called again, and P not equal to null is false. So it doesn't go inside the if condition. It comes out of the recursive function once, again comes out, keeps on going, and comes out of the recursive display. So all the data has been recursively displayed, 10, 12, 23 and 44 of the linked list. Finally it comes out of the main. This entire process is iterative through all the data elements. So it's a time complexity of order of n. So order of n is the time complexity. So now let's look into a linked list features file. So this is a header file which will be used later in our course. So this is a user defined header file. It has a structure node here. We have added it from the previous creating linked list, and we have also placed the create function here. So create function, whatever the functionality we just saw, has been added to this header file. Okay, so that's it for this video. We have covered the definition of node, creating and displaying the linked list features file. I hope you liked this video, and if you like this app, you want to use this app and want to go through the each step of the code, front moving back and next, then you can use this app, Robominions.in AI interview preparation app. Go to the website robominions.in. You can download it. The latest version is available here. Signing up, Dhananjai Sharma.
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app. And make your coding easy. Thank you for watching this video. Bye.